Hey, good morning. First, fifth, and sixth period. It's a Monday. Whew. It's a sleepy Monday here, the week of Thanksgiving. Mr. Mitchell here. And I'm going to cover some problems that are on your review. Maybe we'll go for one of each style of question, and then we'll kind of see where we are. We have first period in the room this morning. Hello, first period. Anybody out there?
Hi.
Crowd goes wild. Let's put the glasses on for this one. Ooh, they kind of fog up though. All right. I'm going to take my picture away. I hope you guys are doing well. The message is that we're going to test. So first and fifth period, take a test on Friday, but I'm going to post it to the Google Classroom midweek. So especially those of you at home, you'll see it. And right in the middle of your goal days this week on Wednesday, you will have the test there in case you have to travel for the holidays or you're indisposed on Friday, which is always an interesting day right before Thanksgiving. I'm going to post the test. Sixth period, we'll see the test on Wednesday. So here we go. I'll take my picture away. All right. I'm going to zoom in a little bit. On the board, I'm looking at number 4. Can you guys see it okay from, say, right there? Okay. Translation. If I was looking at the notes for it, let's see. I think the guidance that I'm seeing that makes the most sense is this statement in the notes. Okay, so I'll zoom in as close as I can on that. Any point, X and Y, for a translation, there is, in our cases, integers, positive and negative numbers, that are added to each coordinate. So they should say plus A plus B. Sometimes it's a minus if it's a negative number in the translation directions. But this is on, I think, the second page in the notes that went along with 4.1 for translations. Okay. So we had a couple styles that they wrote this. The one I kind of like is X plus A, written as a coordinate pair, and Y plus B. All right, so I just kind of write that off to the side to help me. And then I look at the instructions. It says translation, 3 units left and 1 unit down. So left in the coordinate plane is a negative x minus 3. This is my negative x direction. And down in the coordinate plane is y minus 1. So we've kind of boiled down the directions for each of these points. Here comes what I think is maybe the easy shortcut. These are instructions that tell me exactly where to put each point. So I'm going to start with point K, which is sitting on the y-axis. And I'm going to move to the left 3 and down 1. 1, 2, 3, down 1. This is my location for K prime. Prime being a translated point, or any other transformed point gets a prime. So now I do the same with all. 1, 2, 3, down 1. This is my new location for L prime. M, 1, 2, 3, down 1. This is M prime. And J, 3 to the left, 1 down. 1, 2, 3, 1 down. J prime. Okay. Straight edge, if you have it at home, really convinces you that you've got a like shape because it should look identical. These are rigid transformations. Translation, reflection, and rotation are all rigid, which means the dimensions of the shape, its size, don't change. So can we convince ourselves? What do you think, team? Does that look like a shape that has moved left and down? And that is translation. There's one paired with it to the left, number 3, that just says 4 units up. So this triangle will not change even in its x direction. It's only going to go y, and it's going to go up 4 units. The test on Wednesday has multiple choice. So they're going to give you pictures. One of them is the correct translation, or the correct transformation. Depending on the instructions, you'll know which one it is. Okay. Let's try number 1, which has a reflection, which is second in the order. It's 4.2 in the book. And it says reflection across x equals 1. If all I have is an x, I can only move back and forth, left and right. So first, I'm going to draw my axis. And I always put the axis on a piece of paper so I can think through it. X equals 1 is one mark, one grid to the right of the y-axis. X equals 1 there. This is my axis, and I like making them dashed so I don't get confused with a part of the shape. So that is my axis at x equals 1. Okay, reflection. Rules for reflection are on the second page of that notes handout. And remember, you can use everything you want on the test on Friday. These give you rules for across the x-axis, the y-axis, reflecting the y equals x and the y equals negative x. What Ms. Sitek said in the notes is if you have, say, x equals 1, you just have to kind of figure it out. There's not a straight transformation using A and B formats. So I wanted to show you one of these. Here's how I think about it. I have 2 points here that are on the axis, y and w. They're sitting on the axis. Here's y, and here's w. Well, if they're on the axis, this point z is going to flip to the other side, and this point x is going to flip to the other side. It's literally going to pick up off the paper, flip over, and pancake back down. That's a reflection. So these are also my y prime and w prime. They will not move because they are on the axis. Here's the short and sweet version of how to get by with these. I want to move z in a reflection like it's in a mirror to the left. So I'm going to count where it is. It's over 1, 2, 3, 3 to the right, up 1. So I'm going to go 3 to the left and up 1. 1, 2, 3, up 1. And this is my location for z prime. X is right at the origin, 0, 0. It is 1 to the left of the axis. And so x prime is going to be 1 to the right of the axis. There's x prime. And when I draw this, I should see a symmetrical shape that is reflected. Let's see, that goes down through y. And then over there. And then there's one line down to w. So there is our reflection. The shape picked up and pancaked to the other side. Up and over. There's reflection. Any questions so far? Okay. So we did 4 and 1. Zoom back in, back out so you can get orientation. I'm gonna come down to the bottom right of the page, and I'm looking at number 6. A rotation, it says. Let's do one of these. Rotation about the origin. Okay. Rotation 180 degrees about the origin. So I get out my rules. These help me if I'm that book learning type. If I need a written rule for a rotation of 180 degrees, any coordinate AB will become negative A, negative B. The X and Y will switch positions in the transformed coordinate, and they will have a sign change. That's what's meant by the negative. Whatever the sign of X and Y are, it's going to change for the transformed coordinate. So rotation goes from A comma B, 180 degrees. What did I say? Did I say the wrong one? Excuse me. 180 degrees, A comma B is negative A, negative B. Excuse me. There is no position change. It is just the sign change. Okay. Negative A comma negative B. All right, so I can do things like, let's do F. 1, 2, 3, 3, 0. So the transformed just takes A and B and changes their sign. 0 has no sign, so it's negative 3 comma 0 for 180 degrees rotation. G is 1, 2, 3, 1, 2, 3, 4. And maybe you'll start to pick up a pattern. Negative 3, negative 4. H is over 1, 1, 2, 3, 4. 1 comma 4. Negative 1 comma negative 4. And I is at 1, 1. Sign change for both. Negative 1 comma negative 1. Okay, so that's going to put, reading from the bottom up, this is my I prime. Negative 1, negative 1. Negative 1, negative 4. 1, 2, 3, 4 is my H prime. Negative 3, negative 4. 1, 2, 3. 1, 2, 3, 4 is my G prime. And negative 3, 0. 1, 2, 3 is my F prime. There are straight edges in the room. You're always welcome to use them. I think it's helpful because it gives you an indication of, if you're real precise about it, you'll see that the size looks good. What happened with this shape, if I use a paper clip to demonstrate, is this would be a 90-degree rotation. It would have been sideways, and 180 degrees rotation, it goes there. So the F pointy bit was coming down, and it is now facing up. And that is your 180 degrees rotation about the origin. Questions from the room? 2.5, all right. Okay. I'm going to zoom out, and I'm going to change pages. Look at this beastie. This one says, oh, lost my camera. back. Lesson is don't rock the camera too much. 2.5, a dilation of 2.5 about the origin. My scale factor is 2.5, a positive number, and it's larger than 1. So this will be an enlargement. This triangle shape will increase, each length of the triangle will increase by 2.5. Okay. Let's write down our original, our A comma B. I'm going to put it on the left. So we have a Q over 1 down 2. Excuse me. We have an R over 1 up 2. Oh, that first one should be a negative, and this one is a positive. And S is negative 1 comma negative 1. Okay. What the dilation page says to me for an enlargement using a scale factor is centered at 0, 0. My K, my scale factor, is just multiplied by each of the coordinates, K times X and K times Y. All right. So we need to do some multiplication here. I'm going to try it in my head if I can, and I will come up with coordinates for Q prime, R prime, and S prime. Will you guys check me as I do these? That'd be helpful. 2.5 times each one of these coordinates will give me my A and B for the new. K times X and Y. So 2.5 times 1 gives me an X factor for Q prime of 2.5, X coordinate. Negative 2 times 2.5, 2.5 doubled, that's a negative 5. How'd I do? Do you guys agree? Okay. Got the same number here. 1 times 2.5 is another 2.5 for the X coordinate. And this one is a 2 times 2.5, a positive 5. And the last, nice, just negative numbers. Negative 2.5, negative 2.5. So this should have enlarged my triangle, still centered at 0, 0. Over 2.5, okay, so that's kind of this mark, and up 5. 1, 2, 3, 4, 5. Up 5, that is my R prime. Over 2.5 and down 5. 1, 2, 3, 4, 5. This is my Q prime. Negative 2.5, negative 2.5. Over here, it's this hash right here in between. 1, 2, 3, in the middle of the box. And that should be my S prime. Well, it's an enlargement. And you know what? If I was looking at multiple choice, I bet they would throw me some reductions to see if I was paying attention. I could have eliminated some answers right away. And then I probably had to choose between 2 enlargements. So centered at 0, 0. That's what a dilation looks like. We multiplied the K times each number given as an X and a Y coordinate. How are we doing, crew? That's 4. That's 1 of each. You guys want to take requests? Offer suggestion? There is up to, let's see, there's 18, 19, 20, I think, in here. So does anybody want to choose another one that seems tricky? before I sign off?
9.
Number 9. Ooh. Rotation 90 degrees counterclockwise about the origin. I like it. Number 9, Jason says. Thank you. Rotation 90 degrees counterclockwise about the origin. Okay, if I use my paperclip again, it's already down here in quadrant 3. So if I rotate counterclockwise about the origin, well, it's like the paperclip's going to spin and it's going to come here against the run of the clock. So the triangle shape's going to be in that general area. Okay. Let's write down some coordinates. Let's bring that up here from the notes. Rotation 90 degrees counterclockwise. Take AB and make it negative BA. Let's see if this works. A comma B, negative B comma A. Okay, we've got B, C, and D. 1, 2, 3, 4. 1, 2, 3. Negative 4, negative 3 for B. 1, 2, 3, 4. Negative 4 comma 0 for C. 1, negative 1 for D. So if I switch their position and only change the sign of the first, okay, let's see if I can do it. Switch their position, 3, comma, and 4. And I need to keep the sign for the one that goes from A to second position, so that's a negative. And my one in the front, I'm going to go ahead and make it positive so everybody can see. B changes sign, becomes a positive. Here we go. C. A. Well, that's convenient. The A just goes to the back, negative 4. And 0 doesn't change sign at all. These always make me think. Okay, my A goes to the Y position. My B changes sign. So that's a positive 1. Let's see if it worked. Over 1, up 1. Working from the bottom up. That's D prime. 0, negative 4. 1, 2, 3, 4. Is C prime. And over 3, 1, 2, 3, down 4. 1, 2, 3, 4. I think it worked. Make it look pretty with straight lines. There you go, Jason. A 90-degree rotation around the origin.
Paperclip.
Counterclockwise. There goes the paperclip, shifting to there. Some people will eventually do rotations by eye. They see like, okay, D is just poking into this next quadrant. So when it comes 90 degrees around, it's going to do the same here. Pokes 1 into the quadrant 1. I think I'll stop the video here, but I can take more requests from you guys if you need. First, fifth, sixth period. Good luck in your review. I hope you guys kill it before Thanksgiving here.